Welcome everyone, I hope you're doing fantastic. And today we'll be looking at how to make an object follow another in Godot, following a smooth trajectory. So one way of doing this is using interpolation. And Godot has many functions or examples of functions for interpolation. For example here, the function in the vector2 or the method in vector2 class, which is linear interpolate. So it takes in a vector, which is the current vector, and a b vector, and returns the result of linear interpolation between this vector and b, the second vector, by an amount which is t, which only describes the speed basically of interpolation, and t is actually on the range of 0 to 1, representing the amount of interpolation. So let's take a look at this. So here is our plane, and let's take an object here. Let's suppose that's a sprite, and a second object right here, or maybe the mouse position. So the first one is on position x0, y0, the second one on x1, y1. What we want here is for the first one, which is x0, y0, to follow the x1, y1 position. The x1, y1 position can be either the mouse position or another sprite or another object. So what we're interested in here is a linear interpolation. So basically, instead of setting the position of the first object to be equal to the position of the second one on all frames, instead we're going to look for a position in between them, described by a linear function. So at a given position x, y, let's say. So our job here now, sorry about that. So our job here is to find out what this x, y position. Basically, we need to find out what y in function of x is. And that can be easily done by expressing y in terms of, linearly speaking, it's going to be equal to a times x plus an offset. So a times x plus an offset, b, let's say. Okay, and basically we're not going to care that much about the offset because actually it depends on the reference, and we can actually just deduce it from the initial position x0, y0. So what we care about is actually the a, and a can be expressed as y1 minus y0 divided by x1 minus x0, and can also be expressed as so because x and y are on the line between x0, y0, x1, y1, we can write that a is equal also to y minus y0 divided by x minus x0. So the y position is actually equal to y1 minus y0 divided by x1 minus x0 times x plus the offset, of course. So we need to actually choose a position x, y on this line right here. And so that's why we have an amount. So the variable for the amount will help us choose a given position on the line. So the closer we are to the x1, y1 position, the bigger the amount is as it reaches 1. And the farther away it is, the closer amount is to 0. That's basically how we can imagine this. So this translates in practice to speed. So let's go back to Godot, and let's create a new scene. Let's add a 2D scene here, no 2D. I'm not going to rename anything. Let's just add a sprite. So what we are going to do here is, let me set the scale to 0.5.5 so that it doesn't cover the entire screen. So what we want is for this sprite to follow the mouse position. And so let's go ahead and save our scene and create a script, attach it to the node 2D. The first thing we want to do is get reference for the icon. So we're going to create an onReady var. So onReady variable var equal, let's name it icon, var icon, if I can spell it right. Icon equals, so that's how you reference it. Let's get rid of this, we don't need it. We need the process function. Actually, let me go ahead and implement a way for a not very smooth movement. So first of all, let's go ahead and set the position at every frame, the position of the icon, to be equal to the mouse position. This is just an example so that we can see what not so smooth movement tracking, let's say, is. So icon.global position equals to get global mouse position. Let's save, run, and play the scene. So as you can see, it's basically what you'd expect. Nothing fancy here. So now that we've seen that, let's go ahead and use the interpolate or linear interpolate function. Let me go ahead and comment that out. So just for clarification, here I'm using get global mouse position. So you can use the position of any other object that's already moving on your scene, and use it as a reference or as a target. So for the smooth movement, what we're going to do is write icon.global position equals to icon.global position, and we're going to use the method linear interpolate that's in the vector2 class. So our b vector, as I said, is going to be the get global mouse position. You can set it to any other position of any other object that's moving on your scene. And I'm going to use an amount of 0.1 just for testing. You can play around with that amount and see what, so you can play around with the amount and see what it gives you. So as you can see, the movement is smoothed out. And that's basically linear interpolation 101. Next time, we'll be looking at an example of a ghost effect implementation using this linear interpolation.